Let us continue chapter 1, number system. Now we have seen that in the last video I told you about the natural numbers, whole numbers, then integers. Integers symbol is z, we can write I also, and rational numbers. If you go down, then it is true. True it is. That means every natural number is a whole number. Every natural number, whole number is a integer, and every natural number, whole number, and integer is a rational number. So if you come down in this sequence, you will find that it is true. And if you are going up, then it is false. That means every rational number cannot be the integer, and every rational number and integer cannot be the w. That means whole numbers, and whole number cannot be natural number. Why? Because 0 is a whole number and 0 is not natural number. So if you go from down and you are going upward, then it is false. And if you come down in this sequence, you will find true. I have written here 4 examples, 4 questions, and we have to write the answer here. So every natural number is integer. Come on, natural number is integer, means we are coming down. So it is true. Right? You have to justify the answer. So every number, you can take any example. For example, 2 is a natural number, 2 belongs to n, and 2 belongs to mean 2 is. So 2 is also integer, that is z. Now every natural number, second question, every natural number is a whole number. So natural number means we are coming down. So again true. Because suppose now 4 belongs to natural number and 4 belongs to whole number also. So this is true. Every integer is a whole number. No. Every integer, now integer means negative number, -3, -4 and so on. This -3 is not the whole number. So it is false. And why you can say that -3 belongs to this one integer, that is z, but -3 does not belong to this whole number. So this is the justification. And the last one, every rational number is an integer or whole number or natural number. Again it will be false. Now, every rational number means we are going from down to up, so it will be false. So give the example, answer, justification on your own. Question 2, find 5 rational numbers between 3 and 4. Now 3 and 4 on the number line I showed you in the last video. So 3 and 4, there may be infinite, there must be infinite numbers. So we have to find 5 numbers, 5 rational numbers. How to do? Now if it is 5 here, you can add 1 to it, it becomes 6. So you can multiply this number by 6. But to avoid all this thinking and all, I have given you the solution that we should multiply by 10. See how to multiply now. See, look at here, 3. Here, 3 can be written as 3 upon 1. I have written here, but it is not visible properly. You see here, 3 can be written as 3 upon 1. And numerator and denominator, we have to multiply by 10. 3 into 10 and down 1 into 10. So it becomes 30 upon 10. Right? So this is 30 upon 10. Similarly, 4 can be written as, directly I have written now, 4 can be written as 40 upon 10. You can write directly. So again we are multiplying here up and down. That is 4 upon 1 multiplying by 10. So 10, 4 into 10, 40, 1 into now. So 3 can be written as 30 upon 10 and 4 can be written as 40 upon 10. Now we can find at least 9 numbers between them. Now what is the next number to 30? 31. So you write down here 31 upon 10, go on adding 1, 32 upon 10, 33 upon 10, 34 upon 10, 35 upon 10. These are the 5 rational numbers between 3 and 4. So this is the answer. You have to write like that. Okay. Similarly, second example is that find 5 rational numbers between 3 upon 5. Now here I have taken already rational numbers. Procedure is same, method is same. 3 upon 5 should be multiplied by 10, up and down by 10. So 3 multiplied by 10, it becomes 30. So 30 upon 50. So here it is written. Similarly, 4 upon 5 you multiply by 10. I have written here. So 4 multiplied by 10, 40. 5 multiplied by 10, 50. So now 3 upon 5 is 30 upon 50 and 4 upon 5 is 40 upon 50, and go by the same way. So what will be the first number? Between number now. So add 1 to 30. So it becomes 31 upon 50. This is the first number. 30. Go on adding 1 in the numerator only. So 32 upon 50, 33 upon 50, 34 upon 50, 35 upon 50. These are the 5 rational numbers between 3 upon 5 and 4 upon 5. Method is same, only here question is different. Now there can be negative number, though it is, these examples are not given in your textbook, negative numbers, but I have taken this negative number also. Procedure is same. Now solution: minus 9 again multiply by 10, minus 90 upon 10, minus 8 multiply by 10, minus 80 upon 10. Now when minus number is there, so you go on decreasing 1, because if we go from left to right, the value increases. So here 90 minus 90 upon 10 is greater than minus 89 upon smaller than minus 89 upon 10. So we have to find greater numbers. So what do you do? One method you remember, here go on adding when positive, and when it is negative subtract 1. So 90 minus 1, 89, 89 minus 1, 88, 88 minus 1, 87, and 87 minus 1, minus 86. So this become greater and greater. We are going to the right hand side. So these are the 5 numbers between minus 9 and minus 8. The last example, the last type example can be there. 3 upon 7. This is 3 upon 7 and 4 upon 5. You see that now denominators are different. When denominators are different, so what do you do? What is the denominator of second fraction? Second rational number 5. So multiply first by 5. So it becomes 15 upon 35. And then what is the denominator of the first fraction or first rational number? 7. Multiply the second one by 7. So up and down by 7. So 7 4s are 28 and 7 5s are 35. In this way what happens? The denominators are same. Remember, our method should be there for finding the 5 rational numbers, or 6 or 7 or 8, whatever the you have to multiply, you have to make the denominator same. You can multiply by 10, you multiply by any number. Okay, now let us see that. So now take 15 upon 35. These are the fraction, and procedure is same, method is same. Go on adding 1, add 1 here. The positive numbers, add 1. What is the next number to 15? 16. So 16 upon 35. I have written 9 numbers. Find 9 rational number. This is different than that. So 16 upon 35, 17 upon 35, 18 upon 35, and so on, and 24 upon 35. You can write any numbers between two given numbers. So this is the answer. Now question is, this is a homework I have given you. See properly. It is based on these examples, and you can solve exercise 1.1. It is based on these examples. So find 6 rational numbers between 8 and 5. Follow the first example. This is based on second. This is based on third. And this is based on your minus negative number. Now here I have written 0. So minus 1 can be written as minus 1 upon minus 10 upon 10. Multiplying by 10, and 0 multiply 0 upon 1. So 0 upon 1. 0 upon 1 can be written. Multiply this by 10. It will become 0. And this will become 10. So it can be written as 0 upon 10 for this example. And go on reducing then minus 9, minus 8, and so on. Write down the answers false. Solve these, right, and post this answer on your WhatsApp group, so I will be checking. I hope that you must have understood. Thank you.